The sun being the most important neighbor of our Earth is also the most important thing as far as day, night, winter, summer, spring, and fall. The explanation for these particular items are the apparent motion of the sun in an ecliptic around the Earth. In the summertime, the sun is high in our sky in the northern hemisphere, and it's summer. In the fall, the sun is on the equator, heading south. In the winter, it's in the southern hemisphere on an ecliptic of roughly 23 degrees 27 minutes. This is the arc that the sun takes. Starts back up again in the northern hemisphere on the equator and continues to our summer again. So this is a very interesting thing, and we want to show by the demonstrator what is known as the declination of the sun and how it works. The declination of the sun is what causes our summer, fall, winter, and spring. The declination of the sun is the movement as it moves from the equator to June the 21st, the highest point in our northern hemisphere, at a latitude of 2327 north. If you were at that latitude, it would pass over your head during the day. Then in March and September the 21st, it's back on the equator again. Then when our winter comes, December the 21st, it's the farthest point in the southern hemisphere that it goes. Here again, 2365 south. That's the ecliptic of the sun, and that's what causes these particular summer, winter, fall, and spring. Using this information, let's look at a picture of the 2-minute star finder. The grid that I have on the 2-minute star finder is for 5 degrees north in the northern hemisphere in this case. 5 degrees north means that we are 5 degrees above the equator, and let's say we're on the Greenwich meridian. So 5 degrees north then is this cross in the white circle here inside the grid. Now this is the 5-degree grid, which is distorted because of latitude and projections. But let's look at this and see what we can learn from it. Now, we have the sun at the maximum northern declination, and it's represented by this circle. This is nighttime. This is when it enters our horizon, comes up in our sky higher and higher till it reaches a height of 70. Then it starts back down again. Of course, we can read off the bearings that it enters and leaves on. And we can figure the time of sunrise and sunset. a straight line from the northern hemisphere gives us the time of sunrise is 5:56, and it gives us the time of sunset 18:04. So we can figure anything out. We can tell how high the sun is in the sky at any time by drawing a straight line from the northern hemisphere to, let's say, 10 o'clock. 10 o'clock, the sun will be bearing from us 060, and the height will be 60 degrees high. So we can do this all day long. This is the summertime. The declination of the sun at that time, on July 21, is north 23:26. As time passes on, she comes back down towards winter again, towards the equator, and hits the equator in September and March, September on the way down to winter, and we can see that it's just a little bit south of us. It passes almost over our head directly. That's on March the 21st, and it's on the equator. So it forms this arc. Here again we can read off the time of sunrise. We can read off the time of sunrise and set, that is. And we can tell when it's nighttime. We can tell when it's daytime. And we can tell how high she's in the sky at any time. In this case, she's just barely south of us on the equator. And this is, of course, March the 21st. Then she settles down again, going to the southern hemisphere. And at the southern hemisphere, it follows this green circle that I have outlined. Here again we can read off the time of sunrise, the bearing of sunrise, and sunset. We can tell how high she's going to be in the sky in the winter time. It's roughly 65 degrees. So at any time we can figure this out. And that's the case of us being at latitude north 5 degrees. Now we have a different situation. If we were at 85 degrees near the pole, this is how the sun would work. Here again we've got the sun in the summertime. She's above the horizon. So we call this the land of the midnight sun. At midnight, which is up at 000, she's above the equator roughly 20 degrees. She circles and roughly 30 degrees on our longitude of Greenwich, England 0. So here again we can read off time and height of the body continuous for the land of the midnight sun. Now when it's on the equator, it's this particular circle, and here again we can read off time. We can read off the fact that she really is above the horizon, or nearly so, most of the day. She goes below the horizon 180 degrees from us at midnight and comes back to the horizon again when she approaches us at the longitude of Greenwich, England. Now the green line is December the 21st. Now in this case she's below the horizon the whole time. So this means there is midnight, the land of the midnight, period. No light at all coming through, except for bits. She's well below the horizon, in fact, as much as 12 degrees. She's higher slightly where we are, our meridian, and she's farther from our line of sight or our visible horizon during the time that near midnight. So this is how things work, and this is what we would say is the land of the midnight sun.